variation. We've got some targets relating to it. Inverse variation, let's just see what it is. So the first thing we're looking at here, right, everybody's got their notes, is direct variation. Y equals kx. Okay, now let's look at the difference between direct variation and inverse variation. Please stop talking. Y equals kx is direct. Look at inverse. Y equals k over x. So constant variation multiplied by x gives us the direct, and k divided by x is inverse. Now this constant of variation k, it means the same thing in both. Constant of variation. It will be a number, a constant number. 5, 10, right? It's a number. Now in direct variation, the way direct variation works, if x gets bigger, so does y. If x gets smaller, so does y. Now inverse is opposite direction. So if x gets bigger, y gets smaller. Now think about a fraction. 1/2 versus 1/3. If you love pie, would you rather have a half a pie or a third of a pie? You love half. Half is bigger than a third. So as the number gets bigger in the denominator, right, the entire number is really getting smaller. So as denominators get bigger, your value gets smaller. And the other way around is true too. So if your denominator gets smaller, your value gets bigger. So on a conceptual basis, the difference between direct and inverse variation, if this grows, so does your y. If your x gets big, your y gets small. If your x gets small, your y gets big. Okay, so that's the big difference. Now, when we have y equals kx and I want to solve it for k, now we did this, right, for direct variation. What was k? Solve for k. All that involves is saying divide both sides by x. There's your 1. X is not 0. There it is. Now think about how you would do that to solve for k. If I want k by itself, what should I multiply both sides by? You know, right? X. Right? Because remember that knocks out your denominator. Multiplication property of equality says do it to both sides. K equals xy. Wow. All right? So if you have y equals kx, then you divide the numbers to get k. If you have y equals k over x, let me get rid of these markings here. Then you multiply the variable, you multiply these two variables to get k. So it seems confusing. My recommendation is whenever you're going to be working problems, take out a piece of scrap paper. You're going to make 2 columns, one for direct and one for inverse. So whenever you're going to work these problems, just do this. So you write out your basic equations, then you solve for k for both of them, and then you refer to it. Because that way you're not going to make a mistake. Kind of make your own little formula sheet when you work with this. My advice on any test is when I say you may begin, you take out a piece of scrap paper, you write down stuff that is important to remember. So we can talk about what would be good things to write about for your next test. But this is one of those things, right? So I'm always going to keep that nearby where I can see it. So how can I tell if I have a direct variation or I have an inverse variation? Solve it for y. If you solve it for y and it looks like this, it's a direct variation. If you solve it for y and it looks like that, it's an inverse. So how do I solve this for y? Divide both sides by x. Okay, now look at this. Does it look like y equals kx or y equals k over x?
Y equals k over x.
So what is this?
Inverse.
Inverse.
And what's the k value?
Negative.
Yeah. All right, let's solve this for y. How do I solve that for y? How do I solve that for y, Claire? Yeah, multiply by 2 on both sides. Knocks this guy out. We always put the number in front of, right, coefficient goes in front of the variable. Which one does this look like?
Direct variation.
Direct. It looks like y equals kx, so it's a direct variation. What is the k value? 2. Okay, what about this guy? Now it's already y equal. Alright, y equal. Alright, I'm done. So does it look like this or this? Well, it looks mostly like this, but it's not a plus 0.
Yeah.
So it's neither. So you either have an inverse, you either have a direct, or maybe it's not either of those things, neither. Okay? So that's what you do. You solve it for y, and then you decide what it looks like. Okay? So those are the examples in the middle of the page. Okay, direct versus inverse. Let's kind of summarize what we've seen so far. So for direct variation, y equals kx and k equals y over x. Solve this thing for y. Inverse variation, y equals k over x. So multiply by x to both sides to get your k equals xy. So the memory piece are these two things. Yeah, you do have to memorize that. This can be derived. So I would say, okay, solve it for k, solve it for k, write it down. Conceptually, when your x gets bigger, your y gets bigger, or if your x gets smaller, your y gets smaller. For this one, if your x gets bigger, your y gets smaller. When you graph this, I can always tell if I have a direct variation if I have a line that goes through the origin. Now the graph on an inverse variation is a little more complex. Something called, this weird looking word, hyperbola. It sounds like that English word, right? The word in English. It's not though. The hyperbola is the best thing ever. I guess I just made a hyperbole out of a hyperbola. But we'll see what that is. Was there a question? I thought I had that someplace. Was there a question? Okay, what's your question? Well, this is a divide. Let's put a number here. This is y equals 2x, and this is y equals 2 over x. Now, if you solve for this one, right? If I want 2 by itself, 2 equals y over x, doesn't it? Divide both sides by x. If I want 2 by itself, I multiply by x. So you get your constant by multiplying x and y. You get your constant by y over x. Okay? So let's just see, what is this hyperbola? This is the part that's easier if we do this later in the year because we've done different kinds of graphs. So far we've only done linears. But this graph is different. We have what are called conic sections, and we're going to be looking at some of these later in the year. A conic section is, you have to picture like 2 ice cream cones, and you kind of put their points together. And so these are called conics. A section just means a cut. So if I were to cut like straight through it, I get a shape here. This shape here is called a parabola. We're going to be learning a lot more about those later in the year. If you cut across, you get a circle. If you cut sideways, you get this like sideways kind of circle called an ellipse. This you learned about in geometry. This one's more in pre-calc. If you slice through both of them, you get this thing called a hyperbola. You get a piece here and a piece there. This is also like a pre-calculus topic for real. But we do see it a little bit now. And so, let me look at the graph here. This is what they look like. So, see like a piece here, a piece here? These are like different branches of a hyperbola. And they have this thing called asymptotes. It's a lovely little math word. What it means is these little things here, you have to picture the x and y axis as being kind of like brick walls. So picture these like a brick wall coming out at you. So if your line is kind of traveling along, it can't cross that brick wall, and it's like maybe it's a burning hot brick wall. It can never touch it. So an asymptote says that at this line here, we're going to get really, 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 really close, but we are never going to get there. We are going to get really, really, really close, but we're never going to get there. It's never going to cross it. It's never going to touch it. Same thing up here. That's what it means to be an asymptote or asymptotic. Yes? They're not necessarily parallel, but they don't touch it. And I like using Zeno's paradox as an example of never touching it. Do you guys know what Zeno's paradox is? No. Say you wanted to, I wanted to go to that wall from here to there. Okay? So I measure the distance and I go half as far. So I go half as far. So I'm closer, right? Not quite there yet. So I'm going to take half again, right? So I take half that distance and I walk to it. Not there yet, so let me take half. Yeah, I'm getting real close now, aren't I? I'm going to keep taking half. I'm going to keep taking half. I'm going to keep taking half. Will I ever get to this wall if I keep taking half that distance? No. You got to really think about that.
Yeah.
It's like, well,
Yeah,
sure.
you will.
Well, wait a second. I'm taking is. I get so close, but I have to do it like an infinite number of times, and I can't do anything an infinite number of times, right? I just can't. So an asymptote is the same idea. And when you think about this, why can I never be at 0? Why can x never be 0 for this? What happens if you get to 0? Then I'm dividing by 0, can't do it. So math gets really kind of cool and mind-blowing when you start looking at stuff like this. So it's never going to reach, never ever. It's like these big brick walls that are maybe a little, I don't know, radioactive, so it repels it a little bit. So using like a graphing calculator, and I'll just use mine, you can use yours if you have it. I'm going to graph y equals 10x, 10 over x rather. 10 over x. And so there it is. That's what a hyperbola looks like. Or an inverse variation looks like this if you graph it. Okay, so I've got quadrant 1 and quadrant 3. I've got these branches. Now I can have negative, what do we do here? I can have a negative k. So if I make this a negative k, what happens?
So the second and the fourth quadrant.
Yeah, it switches the branching. So a negative kind of moves it the other way. So these are really, really cool kinds of functions. And again, you get to do a lot more with these. A little bit in Algebra 2, more in a pre-calculus class, working with hyperbolas. And we're going to work with the parabola, but that's a little bit later. So that's what it looks like. It's kind of cool. So I need to go here. I may not go here. The graph is a hyperbola. It never passes through the origin because I can't have it over 0. X can never be 0. It never crosses these axes. These are what we call asymptotes. They will never cross the axes. They're always contained in here. But if I make it negative, it will just switch where it goes. All right? So the only reason I'm asking this is so we can compare the graphs. Direct variation, line through the origin. Kind of easy. An inverse variation is a hyperbola. You might see them in quadrants 1 and 3 for a positive k, or quadrants 2 and 4 for a negative k, but they always kind of look like this. So I'm looking at these graphs, and they're on the bottom of page 1 here. Can I tell, just by looking at the graph, do I have a direct variation, do I have an inverse variation, or it's none of the above? It's neither of those. So, yeah, let's look. What's this? Can I tell?
Direct.
Why is this direct? Straight line, right, going through the origin. And just because it goes through the origin, I want you to remember this example of it goes through the origin, but it's not direct. So you need more than it goes through the origin. It has to be a line. What about this guy? This is a hyperbola that goes, right? I'm in quadrant 1, quadrant 3. I'm not crossing any of the axes. That's an inverse. What about this one?
No,
Neither.
Is it inverse or is it neither?
Neither.
Why? Is it neither or neither?
Because it's touching the x-axis.
Why?
It's not direct variation because it's a
And it's not a straight line. Right.
It's not inverse because it's
Good. Awesome. Crossing. Is this even a function? Look at this guy. Is that a function? It's not even a function. Right? It's not an inverse. It's not a direct. What about this guy? Why is this one not a straight line? Why isn't this a direct variation? Why not?
It's not going through the point of origin.
Not going through origin.
And it's not an inverse because it's crossing the axis.
Right, and it's not hyperbola, right? So, exactly. So just by looking, if we just have a graph, we can tell what they are. Which is another hint. So let's say you're like trying to decide, I don't know what they are. Is this an inverse? Is it whatever? Try graphing it. If you get it in Y form and you're still not sure, you can graph it, and if it looks like a straight line through the origin, it's direct. And if it looks like this kind of a hyperbola, it's inverse. So graphing can help you. All right. Next page. Remember how we did tables with the direct variation? And you can kind of figure out? You can do the same thing with an inverse. The difference being, okay, y equals k over x. How do I find k again? With an inverse? Multiply x and y. So before, when we were looking at is it direct, we used to do y over x. That's how you test for is it direct. I want to test if it's an inverse. So I do xy. So now I multiply. That's easier, right? Do a negative 5 times a 2.4. What do you get?
12. Negative, or
Negative 12. Negative 3 times 4. 4 times negative 3. 8 times negative 1.5. Yeah.
Okay.
24 times negative 0.5. That one I
Yeah, that
see.
is.
See how they're all the same? So my k is always negative 12. I got there by multiplying. This is an inverse variation. So xy equals k. Multiply those values. If you get the same k for all of them, you have an inverse variation. Now, if you weren't sure, you think, well, maybe that didn't work. Maybe I have a direct variation. To find the direct variation, you test y over x, and you get the same number. Okay, so this one is an inverse variation. The k is negative 12. What is the inverse variation equation? Yeah, Noah? That would be if it's direct,
Oh.
right? So let's go try again. Excellent. Very nice. So now you got to keep track. Am I working with inverse? Am I working with direct? If it's direct, this is your model that you want to set up. Okay? Who followed? Raise your hand like, yeah, okay. Ish. All right. Let's see if we can do some more of these. So let me just go through a little summary here. If you're given a table of values, determine if data is a direct variation or an inverse variation or none of those. For a direct, you divide y over x and you should get the same number every time. If that's true, that y over x is your k, y equals kx. That's your equation. If that doesn't work, try multiplying x times y. Try multiplying it. If you get the same number, then it's an inverse variation, and that's your k, and it's y equals k over x. So, let me see, I think this is on there. Is this direct, inverse, or neither? So you're like, I don't know. So let's try y over x first. Will this tell me inverse or direct? This will be direct. So that's my direct test. Y over x, 15 over 3. 25 over 5. That's 17.5 divided by 3.5. Use a calculator. Get 5. So y over x, I'm getting a consistent k. So is this a direct, inverse, or neither? What would the direct variation equation be? Right? Because, again, you should have a little place that I would keep this always nearby. Y equals kx, k equals y over x. That's direct. Inverse, y equals k over x, so k equals xy. Oops. You keep that handy. All right, let's look at the next table here. Let's try y over x. See what happens. Maybe it's another direct. What's 1.4 divided by 10? 1.4 divided by negative 10. Is it what?
Negative 14.
Negative 14?
And negative 0.4.
Negative 0.14.
This one, right?
Yeah.
Okay. Negative 7 divided by 2. And I don't know exactly what it is, but I know it's not 0.14. So that doesn't match. So is this direct?
No.
Let's try our test for inverse. Inverse says multiply them. Negative 10 times 1.4. That's negative 14. 2 times negative 7. Negative 14. Negative 1 times 14. Negative 14. They're all the same number. Is this a direct or an inverse? What is the inverse variation equation then?
It is. It'll be y equals k over negative 14 over x.
Excellent. I thought I heard the book. It's y equals k over x. You thought about it, plugged in the k. All right, let's see what this one is. Okay, so let's see. Let's try y over x. Y over x. 5 over 10 is a half. 8 over 16. Okay, it's looking promising. 2 over 8. Oh, that's 1/4. Okay, so it's not that. It's not direct. Let's try our xy. That's 50. Now 16 times 8 128. It's not 50, I'll tell you that. And that's like 16. So it's neither. Neither of those things. So you try to test that, see which one works, if any. Okay, we did the equations already. I don't know what this equation is. If it's neither, you don't have to give me an equation. Not yet. Okay, question?
Not yet.
Who's listening? Right, I did all the y over x, if they all don't match, can't do that. So I did the multiplies, also didn't match. So it's not a direct variation.
How did you get
The equation, once you find k, you plug it into the model. If you decide it's direct, you plug k in here. If you decide it's inverse, you plug k up there. Okay, there's an O. Alrighty, writing these inverse variation equations. We're getting there. If x and y vary inversely, now we've got to keep track of how we're varying. And you know that this y equals 6, x equals negative 3. This is an ordered pair. If you want to write it as an ordered pair, you can. It's part of the inverse variation. So how can I write an inverse variation equation that describes this situation? So first thing I'm going to do is write my model. I know y equals k over x. That's where I'm heading with the value in for k, right? How do you find k?
You have to do negative.
Wait, x times y, right? So in this situation, how do I find k? Multiply the x and the y. You just multiply the x and the y. You get negative 18. That's your k. So what's the inverse variation equation? What do I want you to say here? Inverse variation equation. Nope. Has to have y in it. It's got to look just like this with the k has a value. Matthew.
Y equals negative 18x.
Over x. Be careful. This is inverse. So it has to follow the model. You're going to do a lot of circling. If you have like a highlighter, you may want to be working that. Make sure you know if you're talking about inverse or direct. So I'll put my highlighter up here. This one. Okay. Yes?
Why didn't you do 6? 6 equals negative 18.
You could. So let's say you did that. 6 equals k over, what, negative 3?
With no variable.
Because I want the general rule. This is an example. If you're saying 6 equals 8, I know 6 is negative 18 over 3. I know that. That's not a direct variation equation. I want to be able to do part B, which says I have another x value and I'm trying to find the y that goes with it. So I'm looking for that equation with x's and y's. So that when I get to one that says find y and x is 4, well, what are you going to do? You're just going to plug that the x in. So y equals negative 18 over 4. And, what was that, negative 9 over 2? And you can leave it as a fraction, or you can turn it into a decimal for this kind of thing, not so bad. I would just stop right here. Negative 9 halves, that's the value of y when x is 4. Who is with me? Some people are not even looking, are not even paying attention.
I am.
It is really easy to confuse the two. Not that they're hard, but it's easy to confuse the two. Okay, go do some word problems with inverse variation. I think inverse variation is actually easier than the direct, but let's see. So a theater company plans to hire people to build a stage set. The work time T in hours, okay? So we're working in hours, varies inversely. You see how important it is now to know? Am I varying directly or am I varying inversely? This is an inverse. So before when we did equals K, this is going to be an equal K over, okay? With the number of people hired, and think about that. You're trying to build a stage set. So let's say, you have so many people and it takes you 10 hours. If you add more people, should the number of hours it takes goes up or go down?
Down.
Right? So there you go. People go up, hours goes down. That's inverse. Opposite. So let's see what I got here. Time varies inversely. So now I'm doing an equal K over the number of people hired. Oops. Okay, so now I'm setting it up this way. Solve this for K means you multiply both sides by P. So K equals P times T. And then they're going to give you people and time. The company estimates that 25 people working for 300 hours can finish the job. 25 people for 300 hours. You're always going to be multiplying. These are a little bit easier. What is 25 times 300? 7,500. So now I've got 7,500 equals PT. And I'm going to leave it in this form. You could write it like this, but I do find leaving it like this is a bit easier. Because they're going to give you people, or they're going to give you time next. Let's see what they give us. Find the work time. If they hire 30 people, they want to know how much faster. So the people is now 30. But with this one, it's much harder to make a mistake here because you're going to find both. So divide by 30. Divide by 30, that goes away. 750 divided by 3 is 250. So it's going to be 250 hours if you put on 30 people. 5 more people make it go down 50 hours. Is kind of what it's showing us. Yeah? So it's very similar process. It's just that we're varying inversely. Okay? Question? Kind of. Let's do another problem. Yeah.
Why don't we go back to
You can. You absolutely can. But I think for these it's easier because you put the P over here. These are interchangeable. You could do it this way. And that gets a little confusing. It's easier. Is the short answer to that question. Let's try this one. The length of a violin string varies inversely. You better be underlining this because it's different whether you're varying directly or inversely. And the inverse variation is equal K over. What does? The length of a violin string varies inversely as its frequency. Length varies inversely over frequency. Let's turn that into K equals what? L times F. Always multiplying. It's easy. Always multiplying. They're going to give you one. If it's 14 inches long, if that's your length, the frequency is this 450 cycles per second. 14 times 450, 6,300. So I'm going to replace the K now. 6,300 is your length times frequency. Now you're right, I could have put it here. It will be easier doing it this way. You're going to have to trust me on that. Because they're either going to give you a length or they're either going to give you a frequency. Let's see what they give you. Find the frequency if it's 12 inches long. So they're giving me a length. 6,300 equals 12 times that frequency. Now I can divide by 12. The frequency is 6,300 over 12. I did that, and I got, see if you do too, 525, my units are cycles per second. So it's similar. It is very similar to the direct variation. So my advice, be very careful. Circle the important pieces. If it's a varies inversely, it's equal K over. If it's a vary inversely, it's straight up equal K. Set these up. Find the K first. Come up with the equation. Plug in the value they give you. Okay? And that's it. I think I got a little summary on the back here. I'm just running out of time here. Maybe we'll get this next time.